Hi, my name's Sam Hankey, and I'm joined by my colleagues Michael Gerlitz and Stephanie Emedy. And we are engineers with the Studio's Quality Department inside of Xbox. So today we're going to be talking about our intelligent bot automation tech that we've been rolling out to the various titles and studios that we support. More specifically, we're going to be talking about how this bot automation tech is helping us to deliver confidence at speed and at scale. And I'm going to kick things off by talking about how this is helping us with increased scale on the title of Forza Horizon. So if we start by taking a quick look back at the past and previous systems that we've used, we relied heavily on systems like random input, and that's because it gives us a high degree of flexibility with a relatively low cost of configuration. However, being random, it also doesn't really give us very much control. Say, for example, we need to go into the game and carry out a very specific sequence of steps. Well, for that, we would have to look something more along the lines of a scripted routine. And while scripted routines can give us a very high level of control, unfortunately, they're also very expensive to configure. And so for these reasons, both of these systems, neither of them scale particularly well when the level of complexity increases. So on Forza Horizon, what we've been doing instead is to use a new system that was developed by Michael, and it's called the bot brain. So an example of where this was used particularly effectively was back in 2019 when we were validating a new game mode added to Forza Horizon, which is called the Eliminator. I'm going to go and play a video here, but if you're not aware of what the Eliminator is, it is a 72-player battle royale multiplayer game mode. And if you imagine trying to exercise this using human testers alone, that's an awful lot of people to try and organize. Therefore, instead, what the bot brain allowed us to do was to create a reasonably realistic set of synthetic opponents. That enabled us to take a much smaller test team and be able to give them the power of a much larger team. That enabled us to run full-scale tests for much lower cost on a much more regular basis. I also want to call out the fact this is a really good example of automation being used by testers and leveraged by testers, rather than automation being something that just happens very separately and happens in the background. Another set of things that's been happening whilst we've been using the bot brain, we've realized it's been helping us to do things like passing control backwards and forwards between bots and humans. This is incredibly useful for things like troubleshooting. However, we've also realized it offers the potential to use bot automation to get human testers into position so that they can validate a certain area or a certain feature and be able to lower the cost of doing so. Another advantage is the fact that these bots, compared to previous systems, they are much more capable of being able to exercise the real flow that a player would go through. Here, for example, where in the past, we might have had to have relied on certain dev hacks in order to go and get into a menu system. These new bots, they can actually drive up to the real world marker. They can press the corresponding button. And therefore, if we encounter a problem and encounter a bug, we can be far more confident that it is a real issue and not just some side effect of the way that the automation has been integrated. Another power of the bot brain is the way that the urges and actions that it uses, they're much more reusable. So here, where we have a bot that is going around the world and it's smashing into discount boards, this is actually reusing an action that was created earlier for validating the Eliminator. And that's because finding and smashing into a discount board is really not that much different from finding a loot vehicle in the world or chasing down one of your opponents. And finally, one of the most powerful aspects of bot brain is how the urges are completely dynamic. They're constantly reading the state of the world around them. They can also read the state of the brain. And therefore, if, like in this scenario, we find that we have an objective that is particularly difficult to achieve, the bot can notice that and it can adjust its behavior accordingly. Now, that might be like here, where we have a discount board in a very difficult to reach location, or it could be a piece of misplaced geometry or a button that's missing from the game. And this is really powerful. It's what makes this system so much more useful very early in the development cycle, whilst the game is likely to change. Now, I mentioned things like urges and actions. So let's take a quick look at what's going on inside the brain. You can think of an urge like a desire to go and do something. So in this example, we have the urge to go and collect pickups around the world. And there may be several pickups that the bot could theoretically go and collect. Therefore, the brain needs some way to be able to decide between them. It does so using a set of custom considerations. Here, for example, we have a value that is being considered. So what is the value of the pickup? We also have the distance of the pickup. How far away is it from the current player? And by combining these considerations, we can therefore figure out which one of these pickups is going to give us the best trade-off. Now, what happens if we are en route to our pickup and, say, the vehicle comes off the road and gets wedged up against a tree? Well, this is where the power of parallel urges comes in. We can have another urge that's running in the background. We've called it the hand of God. And what it's doing is it's constantly looking to see whether the vehicle gets stuck. If it does, it can then recommend a much higher weighted action to go and reset the car back to the road position so that the brain can reevaluate and then carry on testing. Now, on top of the bot brain, there is actually another layer, the next evolutionary step, if you like. This is called overmind. And what overmind allows you to do is to take a collection of different brains and get them to work together collaboratively. This is really useful in, say, multiplayer scenarios where you might need different bots to carry out different functions. In fact, the example we've got playing out on screen is a hypothetical game of tag that we may want to exercise. And so to validate this, we might need a leader bot, which can, its job is to go and just drive around the world. But then we could take another couple of bots and we could assign them to the follower role, and their job is to go and chase down that leader bot. This is immensely powerful because it can, as I said, you can get bots that are collaborating together now to exercise much more complex scenarios. But we can even go one step further. We can have scenarios that we run one after another, and so we can form this concept of a test pass. Bot brain is now in use on a variety of different titles, as well as different genres. And in fact, the most recent one was Minecraft Dungeons, which of course, Minecraft Dungeons is a dungeon crawler, so it's a very different style of game to the Forza game that we've just been looking at. Now, whilst they may have different urges and they may have different actions, what's important here is that the core of the bot brain, the shared pieces, they're exactly the same. And this is what's really been helping us to roll out very capable and very robust automation, and do so very quickly on an increasing number of titles. And with that, I'm going to hand over to my colleague and the author of the bot brain system, Michael Gerlitz.
Thanks, Sam. So like Sam mentioned, many of our games have some form of automated end-to-end testing, traditionally involving debug tools and scripts. We used this approach for the entire campaign on Gears of War 4, and it was really powerful. They helped us get daily test validation from the game, but it was also challenging to do. So the first issue we saw was there would be a big upfront cost. We needed test associates that would build the scripts for each level, and it also took a lot of engineering to fix any bugs that arose with the automation. These scripts continued to have to be maintained, and if they weren't, they would quickly lose value, and we wouldn't be able to trust what the bots were doing. Because of this, we had built some cool tech for Gears and users that were comfortable with our tools, but we weren't able to transfer this over to automating new DLC for Gears or a different game. So because of these factors, we didn't know how much trust to put in the bot scripts or how much we should continue to invest in bot automation. While they definitely had value, our confidence wasn't really growing over time. So looking at the test pyramid a little more closely, Martin Fowler calls out that traditionally we think of end-to-end tests as expensive, slow, and unreliable. But at the same time, he has a footnote that if you can make high-level tests that satisfy these conditions, and they're fast, reliable, and cheap to modify, then you don't need so many low-level tests. And I thought, hey, we want to apply bots more effectively and on more titles. So how can we make them faster, easier to change, and more valuable over the lifetime of a game? And the answer was a bot brain, something a bit more intelligent and adaptive, while still technically very similar to bot scripting, something we wouldn't have to update quite nearly as often. So the brain uses the same actions we'd use for scripted automation, such as move to a point, or move to a capture ring or pick up a weapon. But because it's controlled from outside the game, we're constantly checking what's around the bot, what's in the world, and what it should target. And we're easily able to adjust what the bots are doing. So you can see here the Gears 4 multiplayer brain. And this isn't a fixed script. It'll work on any level that has a working nav mesh. And it'll go find enemies or items and go pick them up or go attack things. Further, we found we could use this same brain on DLC for Gears as well. And we could take this system out of Gears and reuse it on other game titles and other Unreal Engine titles as well. Now we'll cover how to make a brain. The inputs are bot actions or controller inputs. Generally, we try to make these very high level, like move to an XYZ coordinate or attack an enemy with some given ID. The actions can report back if they worked or not, using some sort of telemetry event or another type of validation, such as by inspecting the visual data. So here we can see the overall picture of the bot brain, with the actions being pushed into the game client by the brain on the right. We don't have to understand all the details in this diagram, but the first thing that we need for the bot brain is a game state system. We wanted something that we could get data outside the game into C# code, and we found console commands in Unreal Engine would make this possible. We optimized it a bit, turned it into a tool, and here you can see we can easily get all the actors in the game and all their properties. This was really useful since we wouldn't have to check in new game code to iterate on the brain or to add a new feature or fix a small bug. Also, by caching the queries, we could reuse this data instead of hammering the game every time we need a new piece of data. And there's one final advantage, is that we can use this data for other tools beyond automation, such as for filing bugs. So the other piece that we needed for the bot brain was a brain. The first option we looked at was state machines. We had some success with these in the past. They're pretty common in game AI and quite a powerful tool. But at the same time, they can be just as fragile as bot scripts. This is an example of a state machine monkey, something that we would use to test one of the Forza Horizon games. And we can tell it's pretty complex and there's a lot of pieces, and I wouldn't want to have to debug this. So we looked at some alternatives, and one we really liked was a utility AI. And the promise of it is instead of tweaking low-level logic, state machine arrows, or even C++, instead we're dealing with high-level sliders and configuration that almost anyone can work with. So the first piece are the urges. I mentioned we built the first brain for the Gears of War 4 multiplayer, and I found that we could repurpose that same brain for different game modes in Gears with just a few tweaks or new urges. Similarly, we could reuse these brains on Gears 5, and we didn't have to throw them all out and start from scratch with new automation. Here you'll see an example of a very simple urge, and it takes the game state and the bot to the control as inputs, and it generates the recommended actions for the bot. This one just picks the closest goal and tries to move the bot there. But the cool part is since the goals are generated dynamically using the game state, we don't have to change any of this code when we want to apply this urge in a new place. Since the utility AI is really just a bunch of math behind the scenes, we can easily add in metrics if we want to get coverage of specific test goals. So here's an example of a consideration. And it's just ranking actions based on how close they are to the player. So this multi-purpose kind of flexible utility AI architecture also lets us easily turn off an urge, or if needed, add in a hand of God urge to get the bot unstuck. And we don't have to update a bunch of scripts every time one of these issues arises. A good example of this was on Gears of War 4. Whenever a level changed or a new in-game tutorial was added, the bots would get stuck and testers would have to go update a bunch of scripts. While on Gears 5, when an issue like this would come up, they would let us know. We would quickly update the brain one time and it would handle it without much extra effort. So bringing it back to the 3 points about making automation faster, easier to modify, and more reliable, the first thing we needed was a more adaptive AI, which helps us implement tests once and ensure they can be reused. The next thing we needed was reflection and external code, which gives us a great deal of flexibility and makes us less dependent on the game team's development cycle. But it's also important to call out we don't lose reliability with these techniques, and we can still write high-quality automation with simple, standardized tools and libraries. Now I'll hand it off to Stephanie for the last section on confidence, which builds on top of these systems. Thanks.
Thanks, Michael. As Michael mentioned, I will talk a little bit about how having a common tool set helped increase the confidence in our automation system and continues to help increase that confidence in the system and the results that it provides. First, I'd like to revisit some of the concepts my colleagues talked about related to some of the previous automation systems. As a central tech team, we support several studios at different production stages, and that number only grew over time. Without a shared tool set, automation systems were unique to each studios and often unique with each game, even within the same studio. What this meant was that our developers had to spend a lot of time learning or relearning some of the tool sets and code bases they had worked with previously as they cycled through projects. This high maintenance cost caused long waits between feature requests. If automation stopped working for any reason, our testers would basically have to revert to manual testing while they waited for updates. This cycle caused issues with tightened deadlines and would often mean that the systems ended up with a minimal or no graphical user interface, which made it even harder for our testers to use because it felt like a black box or something very disconnected from their day-to-day activities. We knew that these were things that we had to fix in our next system to make it more reliable and increase the confidence of our users and our own confidence in developing these systems. As both Sam and Michael mentioned, we've done a lot of work on the development front. We identified common components that previous systems had and were useful and created standard libraries for these components. Some of these were a remote procedure call library that we used to communicate with the game client. There were several iterations of these over the years, with the latest one being Bifrost. Our game state querying and caching library that Michael already mentioned, and our BotBrain utility AI automation, which manages all the common urge, waiting, and action recommendation systems. Finally, the game systems then are able to add bot automation by simply using all of these and consuming all of these libraries and creating their own game-specific actions and game urges, while it's much faster than reinventing the wheel and creating a new system for your game. This means that we can now easily spread the automation system across different studios at the same time, independently of where they are in their production stages, when they're using the same exact infrastructure, and the only thing that's different is the urges. And we can focus a little bit more on adding automation that matters for the team and cover a lot more scenarios. A great part of these being standardized and modular and extensible is that we don't have to use them all combined. Like, it's not a requirement that we use all of these components together. For example, one of the titles on the screen, only one of them used our provided remote procedure call library. The other two had their own already implemented, and we were able to build the bot automation on top of the systems they already had. And so this is a very powerful and flexible system. When looking at our user experience, what are the testers going to run in their day-to-day activities, we knew that there was a lack of UI and a lack of empowerment and autonomy from the tester's perspective. So we applied the same standardization technique when it came to the UI component. We built a configurable UI for Gears 4 automation within our own internal test assist tool that you can see on the screen called Phoenix. And then after we had something we were very happy with, we pulled all the common components and views into a standard library and shared it with NuGet. With this package, our users and developers are able to create new brains, configure urges, easily start and stop automation, and view logs without any additional code besides the automation code that they created, their own game actions and urges. This is incredibly powerful because now you take a lot of work that would have gone into creating your own unique UI and just have to focus on your own game-specific urges and make sure that the parameters that you want are configurable in the UI. And this also means that the learning curve is it's removed and almost reduced for our shared resources like our testers that are constantly switching between different projects. With a single system, a single common UI, there is no learning curve. They are able to swap between a project. They see that it's on BotBrain. They know what they have to do. And they basically just need to learn, okay, what is the brain doing for this game? What are the urges that I need to learn? And how do I modify them to get the behavior that I need? As Sam mentioned, since we created the BotBrain, we've taken on a lot of tester feedback and expanded on the system with Overmind. And Overmind is the next evolution of BotBrain. It uses a lot of BotBrain's features and functionality, and it's built on top of the brain urges. And Overmind provides tools to set up and run automation from a pool of devices with simple, high-level flexibility to control what the individual bots do. Testers can launch a specific quality pass on, for example, a single-player scenario, a matchmaking scenario, or a load testing scenario, all from a single button click, and launch that on hundreds of devices at the same time, while maintaining configurability and being able to view all those logs on their screen. In summary, the modular and shareable toolset is easy to maintain and contribute. We have shared our code across different studios with different partners, and with that, they're able to contribute and make the code better. And this means that not only they get the benefit of the features that are important to them, but every studio that also is using the same code base and the same packages get those features and get those bug fixes as well. It also allowed us, it gave us time, like providing this work as an infrastructure gave us time later to focus on the user experience and allow us to create a UI in which testers can quickly configure and manage their automation and feel that they have autonomy to change the behavior of the brain without having to plug an engineer for a code change and that it would have to do in previous scripted automation systems. This creates a shared expertise across not only our team, but our different studio partners and our testers. And it drives usage and ownership and encourages people to provide feedback, and which leads to a better automation system over time that everyone can benefit from. This better automation system leads to a higher quality game. And we can cover more scenarios than ever before, all from a single device from a robust and reliable set of toolset. I'd like to thank Sam and Michael for joining me today. This concludes my section. Thanks everyone for watching, and I hope you enjoy the rest of GameStack Live.